In section 4 of the prerequisite chapter, we're going to be looking at polynomials for the most part, and then we're also going to be looking at special products whenever you're doing foiling. So all these things again should be review for you. And so when we're thinking about a polynomial, I'm just going to make up a polynomial. So let's say we have, whoops, would help if I get the pen, sorry about that. So let's say that we have 16x minus 8x to the fifth plus 7x to the third minus 14x squared minus 5x to the fourth plus 3 plus 20x to the sixth. So there's a polynomial. A polynomial can be one term or it can be multiple terms. And a term we've talked about already, like terms, but a term is contains variables and or values, numerical values. So in this case, I just made my polynomial with a single variable in it. Now, when we talk about certain things, like in part 2 where it talks about standard form, the degree, and the leading coefficient, in order to answer the degree and the leading coefficient, you have to be in standard form. So standard form is whenever your terms are written so that the exponents are in descending order. So I'm going to rewrite my polynomial so it's in standard form. So 20x to the sixth minus 8x to the fifth minus 5x to the fourth plus 7x cubed minus 14x squared plus 16x plus 3. So you must have exponents in descending order. Now the degree of the polynomial and the leading coefficient of the polynomial come from that first term. So my 20x to the sixth is where I get that answer. The degree of the polynomial is really just your highest exponent. Okay, in this case, my degree would be 6. Guess I can write this out. And your leading coefficient of the polynomial is simply the value that you have on the leading term. So your first term is referred to as the leading term. So my leading coefficient is 20. My degree is 6. Now certain degree polynomials have special names. First degree we refer to as linear. Second degree is when you have the squared, so that's your quadratic. Third degree is your cubic. Fourth and up degree, they just refer to as whatever it is, nth degree. So fourth degree, fifth degree, sixth degree, whatever it is. So here our degree would be 6th degree polynomial. All right, now when we get to part 3, foiling, we already talked a little about that in our last set of notes with rationalizing the denominator. So just as review, it stands for firsts, outers, inners, lasts. And this is only used whenever you're multiplying two expressions, two algebraic expressions. Okay? So when we look at these examples down here, FOIL does not even apply to letter A and letter B. Because in letter A we're adding, and in letter B we're subtracting. So just don't try to FOIL those. We're just going to add the like terms in letter A between our two expressions. So I'm going to take the squared terms and get 8x squared. We're going to take the x terms and get minus x. and then we're going to take the constants and get minus 12. And there's your simplified version. When we're subtracting, you want to be careful about that because you're really subtracting each of these terms. So I often rewrite it out. Minus 5x to the fourth minus 3x plus 5. 7x to the fourth minus 3x squared plus 2. And now we can do it in the same form. So 7x to the fourth minus 5x to the fourth gets me 2x to the fourth. My minus 3x squared. Oh, I don't have another 3x squared. I almost circled that one that wasn't. Then we get our, I'm going to make this a square instead. My minus 3x, and then we do have constants here. Plus 2 and plus 5 gets me plus 7. So that would be my simplified form. This subtracting, this distributing the subtraction sign is a common error for students. I don't know if you just get too quick in what you're doing or what, but don't make sure that one doesn't catch you. Now these would be examples of FOILing. So we're going to multiply our firsts, get 6x squared, our outers and get minus 8x, our inners and get plus 3x, and our lasts and get minus 4. And then combine any like terms. So we get, now this should really be review for you, and you should really be able to FOIL pretty quickly at this point. So I would ask that you pause the video, do the next two examples, check your answers. So again, I'm going to do firsts and get 3x cubed. I'm going to do outers and get minus 15x squared. Inners plus 2x. Lasts minus 10. No like terms, so that is simplified. And our last one, you can't really do FOIL because you have more than two terms in one of your expressions, so it's more like distributing. I'm going to distribute the 7x squared first and get 21x squared plus 14x squared. Whoops, mistake, 21x cubed. Sorry about that. It's working too quickly. Then we're going to take the 8x and distribute it into the other expression. So we get plus 24x squared plus 16x. And then last, make sure you take the negative one, also distribute it. So we get minus 3x minus 2. Now we do have some like terms we can combine. So I'm going to get plus 38x squared and plus 13x. Almost wrote plus instead of minus. And there's my simplified form then. Now, when we look at special products, there's two different special products that they really looked at when you did FOILing and multiplying expressions in the past. One is sum and difference. So that's when I have two terms. So let's make it x and y to represent my term. And I'm multiplying the sum of those terms by the difference of those terms. So there's a shortcut method here. It's not that you can't FOIL it, because you can, but the shortcut method is that this turns into x squared minus y squared. Now, when we're in the part of this chapter where we're multiplying, again, you could FOIL that. What happens when you FOIL it is you get x squared, and then you get minus xy, and then plus xy, and then minus y squared. And these two middle terms turn into 0, and that's how you get your answer. So it really wouldn't be that much longer of a process. Where it's going to be more important is that you can recognize it in a backwards manner so that you can take this expression that we ended up with and factor it back into this. And that's where it's going to become more important for you. If we look at the second special product, this is the square of a binomial. So again, if I have two terms, I'm either going to have the sum of them or the difference between them, and we're going to square that binomial. Now, the shortcut method is this. You square the first term and you square the last term. But a common error that students make is they think that's all you have to do. When in reality, if we look at it, x plus y quantity squared means that I have two of those expressions and I'm multiplying them. If I multiply those out using FOIL, I get firsts plus outers plus inners plus lasts. And you'll see in this case those middle terms don't cancel out like they did in example A in special product part A. So what we end up here with is x squared plus 2xy plus y squared. So we have this middle term in here that doesn't cancel out. Same idea with the subtraction, except this time, again, we square the first term and the last term. But to get our middle term, because of the subtraction, we're going to end up with subtraction in this one. So minus 2xy. And again, you could FOIL this out, the x minus y times the x minus y, and see that we get x squared minus xy minus xy plus y squared. And so we turn it into minus 2xy's. Again, this is more helpful whenever you use it to go backwards to factoring than as a shortcut method than when you're multiplying. You just want to make sure that you don't make that common error that students want to do where they say x plus y quantity squared is x squared plus y squared. That is not equal. Okay? So here's some more examples we're going to work through. If we look at letter A, this is sum and difference. So this, if this was x plus y and x minus y, then this turns into x squared minus y squared. So I'm going to take my first term and square it, and subtract from it the second term and square it. And when we simplify this, we get 9x squared minus 4. Again, you could FOIL that and probably do it just about as quickly, but it's better that you start getting used to the process. So if we look at this next one, again, it's a similar sum and difference. So I'm going to do first term squared minus my second term squared. So I get x squared minus 4y squared. Now, letter C is the square of the binomial. So if you remember, we're going to take the first term and square it, and the last term and square it, and then we're going to do 2 times each of the terms. 2 times x times y was that middle term. So we get 16x squared. Oops. Should come out to minus because we had a minus in our original. Minus 8x plus 1. Oops, that's a 2. Bad 2. Sorry about that. If we look at letter D, again, similar process. So I'm going to take the first term and square it. I'm going to take the last term and square it. And then 2 times each of the terms. So we end up with 25x squared plus 20x plus 4. Now if we look at letter E is not the sum and difference because the terms in here aren't the same. And it's also not the square of a binomial, so we're just going to FOIL here. So we get 3x squared minus 5xy plus 12xy minus 20y squared. And when I simplify that, I get that as my answer. So our last example here with FOILing, oh, I guess we got a couple more here, but our last one with binomials and FOILing, we get 21x squared minus 7xy minus 18xy minus 6y squared. And again, combine the like terms. Oops, should be plus up there, I missed that. And that should be your answer. Last two examples deal with when we're not using binomials, predominant only binomials. Here we have a trinomial times a trinomial. So this again, example where you just want to think about using the distributive property. So I'm going to take 3x squared times each of these terms in the second expression. So we get 6x to the fourth minus 9x cubed minus 12x squared. Now I'm going to take this second term times each of those terms. So plus 8x cubed minus 12x squared minus 16x. And last here we're going to get minus 2x squared plus 3x plus 4. That was taking this minus 1 times each of these. Just flip the sign. Now you have to combine like terms. So I get the 6x to the fourth. I'm going to cross terms out as I use them, so I have less to look at. So minus 9 plus 8 gets me minus x cubed. And then negative 12, another negative 12 is negative 24. Another negative 2 is minus 26x squared. And then we've got a negative 16 plus 3, which is a negative 13, and plus 4. And now we're going to look at our last example. So this would be a great time to pause the video and try it on your own if you haven't done that yet. Again, trinomial times binomial. Oh no, this is binomial times binomial, so it's just another FOILing. So I'm going to get 15x squared y minus 12x to the fourth y plus 10y minus 8x squared y. Now this is one that it's kind of hard to know what order to put it in. So I'm going to go by my x's as my main variable. So I'm going to start with negative 12x to the fourth y. And then I have this like term. So we're going to get plus 7x squared y and then plus the 10y that's left over. So hopefully this was a good refresher on FOILing and multiplying polynomial expressions.